Hi, this is Miss Oliva, and we're going to look at zeros of polynomials and analyzing polynomial functions, which is 2.4. Remember, if you are in my 161 class, this is the last section before your next quiz. So make sure after this, you are reviewing 2.1 through 2.4 and sending me any questions you have before you try the quiz. Okay. So when we have been doing polynomials and finding their zeros so far, I told you, remember, don't worry, if they tell you to find the zeros in this section, you will be able to factor. Well, now we're finally at the harder section where you might not be able to factor. So if I was trying to find the zeros of this, I would try to factor it first, which would mean grouping, but I can already see that's not going to work out. So the first thing we have to learn is how to limit how many options we have, because we're basically going to start kind of guessing and checking. So I would rather not have every single number in the world to guess and check. So there is a way to get a smaller list, which is a list of the possible zeros. So these are still not our answers, but it's our list of possibilities, which will hopefully be smaller. So P over Q is the formula, and P is factors of the constant. So remember, the constant is the number that does not have an X with it. And Q comes from the factors of the leading coefficient. So what number is in front of the highest power? So in this case, 21 or negative 21 is my P and 1 is my Q. The signs don't really matter because we know that for negative 21, 7 and negative 3 could do it, but negative 7 and positive 3 could also do that, right? So whatever factors we have, we're always going to have a positive and a negative of that. So when I list my factors of 21, I'm just going to say plus and minus 1 are factors, plus and minus 3, plus and minus 7, and 21. So I'm just listing all of the different factors. So 1 times 21 and 3 times 7 are the only ones I can think of that would go into 21. And then since 1 is my leading coefficient, the Q is easy because it's just going to be plus and minus 1, which isn't going to change anything. Do you see that if I also had a plus and minus 2, that would mean 1 over 1 is an option, but 1 over 2 would also be an option, 1/2. 3 or 3/2, 7 or 7. So it's nice when you only have a 1 at the bottom. So basically, these are my options, where if now I wanted to find the zero, I would start guessing and choosing just from these 8 options instead of every single number in the world. But for this question, they just wanted the list. So I'm just going to list them out now. So again, 1 over 1 doesn't change anything. 3 over 1, 7 over 1, 21 over 1. So you basically just list all the options because of whatever's happening down here. So those are my options. Number 2, which of these is not a possible zero? So before I even look at these, let's just make our list of possible zeros. So I'm using 12 for the top. So plus and minus 1, 2, 3, 4, 6, 12 are all of the numbers that could go into 12. Okay, I'm getting that because of 1 times 12, 2 times 6, and 3 times 4. So you might not do this as fast as I'm doing this, and that's fine. But now, unfortunately, instead of a 1 out front, I have a 6. So I'm going to have a couple options on the bottom. So if I wanted to list this out, it would be 1 plus and minus everything, 1/2, 1/3, 2, 2 over 2, which is 1. So I've already done that. 2 over 3. So do you see how there's a lot of choices this time? But luckily, they're not asking me to list them. They're just asking me to circle or whatever, any that are not a possibility. So do you see that the 5 over 3 would not be a possibility because I don't have a 5 up top? So that one is not a possibility. 2 is fine because I have 2 over 1, which is 2. We have another one with a 5, so definitely not a possibility. and we have 7, which we never had on the top. So all 3 of these are not possible zeros. 2 is the only one. Now, does that mean 2 is an actual 0? We don't know yet. We could find out by doing synthetic division, but right now all we know is it's a possibility. Okay, so number 3 wants us to find the zeros. So again, we start by making our list. I have a 12 on top and a 2 on the bottom. So 1, 2, 3, 4, 6, 12. Over 1 and 2. So I'm now gonna just have to start guessing and checking out of all of these numbers. So I'm going to take my 2, -5, -20, 35, and -12, and I'm going to try something with synthetic division. And if it doesn't work, I'm going to kind of try to see why it didn't work, and maybe that'll help me guess the next number. So I'm going to try 3. I know that's a possibility, right? So bring down the 2, multiply, add. Multiply times 3, add. Multiply times 3, add, which is, I don't want to make a mistake, so I'm just double checking. -16 times 3 is -48. So this is definitely not going to work. So I don't even need to find out. So it seems like we got, I guess you could say this was one of my issues, that this wasn't big enough, because then I had a large number here that made these bigger and bigger and bigger. So I'm going to maybe try something a little larger to see if that helps. Okay, let's try 4. 2, 8, 3, 12, 8, 32, but here it's still going to get big. 67, and then way too big. So maybe it's the fact that we only have positive numbers happening here. Because if this was a negative, it would maybe help. So I'm going to just try -4. 2, -5, -20, 35, -12. This is why a pencil would maybe be a good idea here, because you could just erase and try it again. So bring down the 2, multiply and add. Multiply, add. Multiply, this is still getting too big. I am going to try 1. Okay. 2, -5, -20, 35, and -12. Bring down the 2, multiply and add. Multiply and add. Multiply and add. Multiply and add. Finally. Okay, we found one of our zeros, but we know we're trying to find 4 because it's the highest power. We're always trying to find that many. So the good news is I can now start with these numbers and see what happens. So I'm gonna go, where did I try 4? I just want to make sure I didn't make a mistake here. Oh, I did make a mistake here. All right, I'm gonna try 4. I think I made a slight mistake over here. So bring down the 2, multiply, add, multiply, add, multiply, add. Okay. We have 2 of our zeros. But what's nice is since we have found 2 zeros, that means we've divided twice. So this is now not something times x to the 4th. This is now something times x to the second, and we might be able to factor. So 2 times -3 is -6. Do I have factors of -6 that would get me to +5? Yes. Whoops, it would be +6 and -1. So I'm going to rewrite this. And I'm going to do my factor by grouping. I can pull out a 2x from these two. I can pull out a 1, but that would leave me with negative. So I'm going to pull out a -1 so that then these will match. So I end up with 2x minus 1 and x plus 3, which means my last two zeros are 1/2, because that's what I would get with that one, and -3. So I had to do some guessing and checking at first. Once I found my first answer, I could then use these new numbers instead of going back to all the way to these and keep guessing and checking again. And then once we got down to something which was an x squared, I could try to factor it, which I could. So my final answer for the zeros would be 1, 4, because don't forget these count, 1, 4, 1/2, and -3. Okay. So now it's telling me that a polynomial f of x, and it's going to give me one or more of its zeros. Okay. So if it's telling me that this is my function and this is one of my zeros, even though that's not a nice number, remember we can use that to get started. Because if that's a 0, I should be able to divide it out nicely. And then I could go from there and see if I could maybe factor or do something else. So my numbers are 1, -16, 61, 112, and -476. Bring down the first number, multiply it by that. Add these, which really just means the -16 and the 8. The -2i just stays what it is. But now I need to do this times this. So I'm going to do that carefully down here. And I'm going to FOIL it out. -64 minus 16i plus 16i plus 4i squared. So this really becomes a -4. So -64 minus 4 is -68. So at least that worked out nicely. Add these together and I get -7. Multiply -7 times this and I will get -56 plus 14i. So now when I add that, I really am only adding the 112 with the -56. So I get 56 plus 14i, and now I'm going to multiply this by the 8 minus 2i. So I'm going to do that down here. So 8 times 56 plus 8 times 14 I minus 2 times 56i minus 28i squared. So these wipe out. And this, since it's -28 times a -1, becomes positive. 448 plus 28 is 476. So that all worked out to this, which means it did actually work. But now I have this crazy looking answer. And we didn't even make our list in the beginning. We just started with what they gave me. But the nice thing about an imaginary number is if you ever have one of them as one of your zeros, you always have the conjugate as the other one, which means if 8 minus 2i is one of your zeros, then 8 plus 2i has to be also. These are called conjugates. So notice that the first number is the same, but it's the second part that changes the sign to get a conjugate. What's nice about conjugates is if you multiply these two together, they will end up as one nice, pretty answer. You'll get rid of all the i's. So I know that 8 plus 2i must work also. So I'm going to start with these numbers, even though they look kind of crazy. And I'm going to divide this by 8 plus 2i. So I bring down my 1, I multiply my 1 times my 8 plus 2i, add these together, and I get 0, right? Because negative 8 plus 8 is 0, and negative 2i plus 2i is also 0. So this whole thing equals 0, which is nice. 0 times anything is 0. Add these together, I get negative 7, and then multiply the negative 7 times the 8 plus 2i, and I get negative 56 minus 14i, which is again 0. And I'm now down to an x squared. So don't forget, these are both zeros. We've found 2 of them. But now I need to take this and see what else there is. So if x squared minus 7 equals 0, I can just solve this with algebra, but make sure you don't forget that when you take the square root of both sides of the problem, you have a plus, plus and a minus answer. So what are my answers? 8 minus 2i, 8 plus 2i, square root of 7, and negative square root of 7. These are my zeros. Now, if they want me to write that instead as a product of linear factors, it means I want to turn each one of these into a factor by bringing in the x. So I'm going to do the easier ones first. Square root of 7 would just mean x minus square root of 7. This one would be x plus square root of 7. This is weird because it's larger than what we normally have, but because of the positive 8, I'm just going to say x minus, and then I'm just going to put this into parentheses. And this is also a positive 8, so I'm again going to say x minus and put it in parentheses. It's not pretty, but these are the factors. I would normally say to multiply these together because they'll end up a lot nicer, but because it said linear factors, they want everything to have just an x in it. If I multiply these two together, they'd have an x squared. So that's why I told you that. I was basically saying don't multiply any of them together. And then now finally it's saying solve the equation f of x equals 0, which means basically find the zeros. So this answer really is the same as part A. So you're just going to list out the different answers. Okay. So that was that one. All right, to write a polynomial that satisfies the given conditions. So we want the lowest degree that would possibly have all these zeros. So we want negative 4 to be a 0, which would mean x plus 4. But then they say multiplicity of 2. That just means we have 2 of them. So I'm just going to put a little square. We have the number 1. So x minus 1 with a multiplicity of 1. So I don't need to do anything here. And then they're telling me that f of 0 equals 96. Seems like they're telling me this for no reason. But the reason is this is one example of an equation that could have negative 4, and 1 as my factors, right? But there's a million different equations that would do this because I could put any number out front and it would still be the same factors. So I'm going to say that there could be some number out front. And with this information, I can actually find what that exact number is. Because there's only one number out front that when I plug 0 into this equation, I would get 96. So 96 is my y, so that would go there. We're trying to find a, and now I can plug in 0 for x. 0 plus 4 is 4. 0 minus 1 is -1. So 96 really equals 16 times -1, so -16a. And then I can divide by -16 and get that a must be -6. So my final equation is exactly this one, where it has these factors, but it also has a -6 in the front. Okay, so if they're ever asking for an exact polynomial that does this type of stuff, that's what that last piece of information is telling you. That to find that number out front, plug 0 in for x and set it equal to this number. Okay. Next rule we're going to learn is something that might help us narrow down how many possible zeros we have to look at. Because remember when we had to guess and check for that other problem, it was kind of annoying and we lucked out that we didn't have to guess too many times, but we could have had to guess 10 times if we didn't find it. So there's something called Descartes' rule of signs, which kind of helps you figure out how many positive zeros you might have and how many negative zeros you might have to kind of help you out. So here's how the rule goes. First of all, when you do this, you can't have 0 as a constant. So in my example here, do you see how I have no constant, which means it's 0? So the trick is, if that is happening, you need to factor out any x that you can. So if I were to factor out an x here, I would get 7x to the 7th plus 8x to the 5th plus 9x minus 1. And now this is what I'm going to focus on to see what's happening with the signs, because now I have a constant that is not 0. So what it's saying is the number of possible positive zeros is the same number as the number of sign changes in f of x. Well, here's my f of x. I'm focusing on this part. What does a sign change mean? Well, this is positive, and this is positive, and this is positive, but that's negative. So this is the first time we had a sign change. So there is one sign change. So what that means is I have one positive real 0. Now, I could also have less than that by a positive even integer, which just means you can subtract 2. But I can't subtract 2 from 1, so I'm just going to stick with 1. How many negative zeros you have is the same idea, except you're using f of -x and looking for the sign changes. So the first thing you need to do is plug in -x to all of these x's. Again, we're kind of ignoring this one for now. So 7 times -x to the 7th plus 8 times -x to the 5th plus 9 times -x minus 1. Since I'm raising this one to a 7th power, it's going to stay negative. So -7x to the 7th. This one will also stay negative. So -8x to the 5th. 9 times -x is negative. And then I have minus 1. So I have no sign changes at all here. So I'm going to have 0 negative real zeros. So I already know one of my zeros is 0, because when I pull this x out, if I set that equal to 0, I would have 0 as my answer. So I have one that's 0, and then I have one positive and I have no negatives. So this is 1, 0. So if they ask me how many positives or negatives I have, that's what we have. Okay, another trick to kind of narrow down what you're looking for is the upper bound or the lower bound theorem. This helps us because when we're guessing and checking, at some point, we might try a number like 7. And if a certain thing happens, that's going to tell me that all of my zeros are less than that number. So that might help me eliminate some of my options. Okay, so we want to try to find these upper bounds and lower bounds to kind of cut off some of our choices. So upper bound, if all real zeros are less than it, it is an upper bound. And if you have a number that all the real zeros are greater than it, we're calling that a lower bound. So again, these will just cut off the numbers so that you can hopefully have less to pick from. So how do you know if something is a lower bound or an upper bound? According to the theorem, let f of x be a polynomial with degree n is greater than or equal to 1, with real coefficients and a positive leading coefficient. Further, suppose that f of x is divided by x minus c. If c is greater than 0, and if both the remainder and the coefficients of the quotient are non-negative, then c is an upper bound for the real zeros of f of x. So basically, we're going to be doing synthetic division to test these numbers, right? So if c is a positive number, and when we divide it out, all of the numbers at the bottom that we get with synthetic division are non-negative, meaning they're either positive or 0, then it is an upper bound. If we're dividing by a negative number, and the coefficients of the quotient and the remaining alternate in sign, so they go from positive to negative. If there is a 0, that will just count as whatever you need it to be, then it is a lower limit. So if this was telling me to find all the zeros, first I'm going to use what we just learned from Descartes, and I'm going to see how many possibilities there are for positives or negatives. So I don't have 0 as a constant, so I'm good to try this. 1, 2, 3. There's 3 sign changes. So that means for positive zeros, I could have 3. Or remember, you can also subtract 2 from that, 1. So I might have 3 positive answers that work, or I might have 1. Those are my options. For negative, I'm going to first plug in f of negative x and see what happens with the sign changes. So this one would stay negative, so it becomes negative 14x to the third. This negative x squared would become x squared, but then it's times a negative 55. This would become negative, and the negative 9 would just stay negative 9. So 0 sign changes. So we either have 3 or 1 positive zeros, which would mean we might have some imaginary zeros, because if we only have 1 positive and there's no negatives, then the other 2 must be imaginary. So we're going to start trying to see if we can find it. So I'm going to first find my list of possible zeros, so I know what to pick from. Plus and minus 1, 3, 9 on top. Because of the 14, I have 1, 2, 7, or 14 on the bottom. I'm going to start with some of the whole numbers, not the fractions. So basically 1, 3, or 9. So I'm going to try 3. So my numbers are 14, negative 55, 42, and negative 9. Bring down the 14, then multiply it by 3. Add these together, and you get negative 13. Multiply that by 3, and you get negative 39. which gives you 3 when you add those. And then 3 times 3 is 9, and I lucked out. But I also, oh, never mind. I was going to say I also have a bound here, but no. So we found one of our zeros, which is great. We also are now into the quadratic. So I'm going to write that down, and I'm going to try to factor that. So 14 times 3 is 42. I'm going to try numbers that multiply to 42 that add up to 13. So there's 2 and 21. That's not going to work. There's 3 and 14. That's not going to work. There's 7 and 6. That could work. So since it's a positive 42 and I want to end up with a negative 13, that would work if they're both negative. So I'm going to rewrite my problem. And then I'm going to factor with grouping. So multiply or divide the first two by 7x. And now the next two by negative 3. And I did what I wanted to do. I have matching stuff in the parentheses. And those are my factors. I can set each of those equal to 0 and solve. And I get 1/2 and 3/7. So I ended up having 3 positive answers, just like I knew was a possibility. So if it asked you for the zeros, they are 3, 1/2, and 3/7. So we didn't really need the upper or lower bounds, but if this 3 did not work and all of these were either 0 or positive, what that would have told me is that all of my answers should be less than 3. So then I would not have to try 9. I would go and try something like 1 or -1 or -9. So that's what the upper and lower bound theorem helps you do. All right. Again, we're trying to find zeros here. So remember that we want there to be a constant in order to use Descartes' rule. So the first thing I'm going to do is factor out x squared because I can, and because that will help me not only get some of my answers, because this will tell me something here, but it will also make it so I can use Descartes' rule. Okay, so I already know some of my zeros. Because of this x squared, I know 0 is an answer, and I know that it happens twice. So I really know 2 of my zeros, and I know that I'm looking for 6. So now I'm basically focusing on this and trying to find the rest of them. So I'm going to start with Descartes' rule. How many positive and how many negative zeros do I possibly have? So first, how many sign changes? None. So there are no positive zeros. So that helps. Negative, I need to first plug in negative x to everything and see what happens. This negative would go away. This one would stay. This one would go away. This one would stay. And the 5 would just stay at 5. So how many sign changes do I have now? Positive to negative. So that's 1, 2, 3, 4. Wow. So they might all be negative, or remember I can subtract 2, and that's another option. Or I might just have 2, which would mean, what are my options? Positive, negative, or imaginary, right? So if I have 0 positive and 4 negative, and we already know we have these two zeros, what would be left? Oops, no. So if we have the two zeros, then we'd have none left, right? If we have no positive, which is our only option, only two negatives plus these two zeros, then I would have to have two imaginary answers. So those are my options. So let's now try to find these answers. So I'm going to use my P over Q to get my list of possibilities. So all I have on top is 5. So that's plus and minus 1 or plus and minus 5. And on the bottom, all I have is 1. So this really means my only options are plus and minus 1 or plus and minus 5. And we've already found out that there's no positives. So I really only have two options. So this has helped a lot. So I'm going to try -5. If that doesn't work, then I know it's going to be -1. But I'm going to try -5 first. My numbers are 1, 2, 6, 10, and 5. Make sure you go back to here. Don't use what happened when we plugged in the -x, because that was not our real equation, right? So bring down the 1, multiply, and add. Multiply and add. Multiply. And add. And multiply, and I can already see this is not working. So I'm going to try -1. Multiply, add, multiply, add, multiply by -1, add these, multiply by -1, and that's better. So that worked. So I was at x to the 4th. I tried -1 and I got to this. So I am now at x to the 3rd. And it looks like I could probably factor this, right? Because I can do grouping. So I can take an x squared out of the first two, leaves me with x plus 1. I can take a 5 out of the next two, also leaves me with x plus 1. So I get x plus 1 and x squared plus 5. So what are my zeros? We already know we have 0 and 0. We already know we have -1. We now know -1 happens again. And now we have whatever we get here, which is not -5, right? Because we have to really solve this because there's an x squared. So make sure you never miss, if there's an x squared, you're not just giving me the opposite of this and finishing. So I'm going to set this equal to 0 and solve. And it looks like there's an issue because I'm going to take a square root of a negative, which is why we're going to have some imaginary answers. So because of this because of the negative, there's an I in front of the square root of 5. And because I took the square root of both sides, there's a plus and a minus answer. So 1, 2, 3, 4, 5, 6. 6 zeros just like I wanted. But now let's answer their actual question. The question was, f of x has how many zeros not counting multiplicity? That means when there's two zeros here, they just want me to count that as 1. So they're basically asking how many different zeros do you have? 1, 2, 3, and 4, because these are different. So there's 4 different zeros. Okay, last question is a word problem. And it's going to involve knowing or remembering the area of a rectangle, which is just length times width. So if we had a rectangle, which is right here, that is bounded by y equals x squared, which just means that's one of its edges, the x-axis, and the line x equals 4. So these 4 things kind of bound our little rectangle here. if the area is 8 inches squared, so we already know the area is 8. Determine the dimensions of the rectangle. So they want me to find how long and wide this is. What is the length? What is the width? So let's look at this. First of all, we're at 4. So we know the distance here is 4 all overall, but we don't know what ours is of the rectangle. So what we can do is just call this x, because that's what this is, right? Whatever the x is the distance here. So since this is 4, what that means is our edge we can call 4 minus x. Since we know the whole thing is 4, and we're going to call this part that we don't know x, we know our edge of our rectangle must be 4 minus x. So that's one of our dimensions. The other dimension comes from this, but it's going to be equal to whatever x squared is there, right? That's going to be our value. So apparently 8 is equal to our length, which is x squared, times our width, which is 4 minus x. So we just need to solve this, and we'll have our x, and we can plug it into those to find our dimensions. So I'm definitely going to distribute the x squared first. I don't notice any nice way I could do it like this. So normally what you do in this case is get everything on one side. But since I have a minus x squared, I'm going to actually get it all onto the other side. So I'm going to add the x squared over there, subtract the 4x squared, and then the 8 will just stay positive. Okay, so I just added the x to the third and subtracted the 4x squared. So now everything's on one side, but I can't factor this. This does not look like anything I can factor. So I'm going to need to use all the stuff we just learned and try to find the zeros. So P over Q would give me 1, 2, 4, and 8 over 1. So I'm just going to go for it since there's only 4 options. I know that I might have positives because there's sign changes. So if there were no sign changes, then I would definitely start by trying some negatives, right? So I'm going to try 2. My numbers are 1, -4, 0, 8. Don't forget to always put a 0 if something's missing. And let's see what happens with 2. We get 1, we multiply and add, we multiply and add, we multiply, and we lucked out. So we have one of our options for x. But because there's still stuff happening here, there might be more options for x. And I think in the question in the homework, it's going to ask you, what are the dimensions? And it's going to give you 2 options to answer that. So you're going to have one length and width that could be happening and another length and width that could be happening. So since I started with an x to the third, I'm now down to a quadratic, which is nice because I can try to factor it. 4 and 2 seems like I'll be able to factor it, but there is nothing. There's no way to get to -4 by multiplying and add to -2. So you could try it if you want, but I'm going to save time and just switch to another method, which means I'm going to try to get these answers with the quadratic formula. So opposite of b plus or minus square root b squared minus 4ac all over 2a. So opposite of b means +2. B squared means 4 minus 4ac all over 2 times a, which is just 1. So 4 plus 16, which gives me 20. Since the whole thing's over 2, I'm going to now just split it up because what that means is each of these is over 2. So I can reduce this first one. I cannot reduce this right now because the 20 is inside the square root and the 2 is not. But I can try to reduce the 20 by seeing if I can bring numbers out. So 20 is 2 times 10, which is 2, 2, and 5. So since there are two 2's, I can bring one of those out, right? And if there's two numbers inside the square root, they come out as one number. And then this 5, since it does not have a pair, has to stay inside. But now that I brought that 2 out, I can reduce. So I get 1 plus square root of 5, or 1 minus square root of 5. But if you do this, you'll see you get a negative number. And if we're trying to find the length of something, it cannot be negative. So my two options for x are 2 and 1 plus square root of 5. So let's just start with the 2. If x is 2, what would x squared be? 4. So that would be one of my dimensions. And what would 4 minus x be? 4 minus 2, which is 2. So one option for my dimensions is 4 and 2. And that makes sense because that would give me 8 as the area, right? 4 times 2 is 8. But now let's come over here. If this was my x, what would x squared be? That one's going to be harder. We have to multiply this all out. So we get 1 plus square root of 5 plus square root of 5 plus square root of 5 times square root of 5, which is square root of 25, or just 5. When you do a square root times itself, the number comes out. So 1 plus 5 is 6. Square root of 5 plus square root of 5 is 2 square root of 5. So that would be one of my dimensions in this case. And then the other one would be 4 minus x. So that would be 4 minus this whole thing. So make sure you use parentheses when you're doing 4 minus more than one thing, because I need to make sure that negative goes to both of these. So 4 minus 1 is 3, but then that negative goes to the square root of 5. So these are my other options for the dimensions, which are not nice, but this times this, if you try it out, will give you 8. So these are the two different options for our rectangle. Okay, that one was not easy, I know. So if you need more help than that, please let me know. Send me homework problems and I'll help show you how to work them out if you need it. And make sure you study before you take your quiz.